Right before Thanksgiving, there was a meme going around social media asking which is the correct way to arrange 4 eggs in the egg carton if you're obsessive compulsive. There were 4 choices: A, B, C, and D. People were voting, people were suggesting others. And I know nothing about which would be the correct way to arrange the eggs, but I think there are a bunch of interesting math questions here, and that's something I really like to talk about. So before we go any further, let's give credit where credit is due. The meme has at the bottom a website called The Farthest Reaches. That appears to be an author's blog that posts infrequently, was active some years ago, and I couldn't find this image anywhere on the blog. I did an image search, and that seemed to indicate that someone recently posted this in a group called The Astonishing School of Gifted Nerds, of all things, and it had a viral moment or two from there which caught my eye. In any case, let's take this scenario and see where it goes. So I would like to pose 4 problems arising from this. The first and obvious problem is how many ways can we arrange 4 identical eggs into the 12 positions in the carton? This is not in any way a trick question. It's the standard question that you'll find in any introductory probability course in high school or college. And I think many people would be able to do this, either reasoning it out or looking up the formula in a text. Now for the next 2 questions, I'm going to gradually take away the ability to orient the egg carton. As it stands, the egg carton has a definite bottom and top, as well as a lid that hinges on the back, so you know how to place it in order to open it. And the egg carton is completely oriented. Top, bottom, front, back, left, and right are all obvious. So now let me change the lid from a hinged lid to a lift-off lid, and now front and back become interchangeable along with left and right. So there are now 2 indistinguishable orientations which we'll treat as equivalent. So question number 2 is, how many ways can we arrange 4 identical eggs into the carton of 12 when we can no longer distinguish the 2 orientations that result from a 180-degree rotation in the plane on which the egg carton is seated? In question number 3, I'm going 1 step further. I'm going to make the top and bottom identical and both capable of holding an egg in one of the 12 positions, top and bottom each having a cavity which together enclose the egg. So now we can rotate 180 degrees along any of the X, Y, or Z axes. And now when the container comes and goes in and out of the fridge, we have no idea if it was spun around left, right, turned upside down, over and over, etc. And we'll have to treat any of the egg arrangements that result from the various orientations of the egg container as identical. So question number 3 is, how many ways can we arrange 4 identical eggs into the container of 12 when we can no longer distinguish any of the orientations that result from a 180-degree rotation about any of the 3 perpendicular axes upon which the container has symmetry? And now the last question. In our previous scenario, you might object to the assertion that you can't tell top from bottom because when you open up the container, it'll be obvious that your eggs are upside down. Eggs have a big end and a little end, and if you've read Gulliver's Travels, you know that you can get into a great deal of trouble if you don't distinguish between the big end and the little end of an egg. So here's how I'm going to handle this question number 4. How many ways can we arrange 4 identical eggs into the container from problem number 3 when we require that 2 of the 4 eggs have the big end down and the remaining 2 have the little end down? Obviously, flipping the egg carton over will invert each of the eggs, and you'll still have 2 big ends down and 2 little ends down, no matter which way you orient the carton. And now you can't rely on the Endianness of the situation to distinguish top from bottom. So now comes the spoiler alert. So if you want to get to work on these, stop the video, go answer the questions, and then see if you agree with the answers I got. This is a nice little problem set, and I think it picks up where a lot of probability courses head in a different direction. I think most probability courses really want to prepare you for statistics, so they don't spend a lot of time talking about how to count outcomes. They want you to move towards studying distributions and show you how to analyze data. This problem probably belongs in combinatorics, and this problem really isn't sophisticated enough to deserve a treatment there. It can be better treated in group theory, but it's kind of a dead-end problem there too. I hope you enjoyed these problems. For more problems like this, check out my YouTube page, which I'm calling Let Me Count the Ways.